relative motion 相对运动
I think we learned this in physics.
Yes,
Yeah,
but not in DSC physics. In GCE, there's a little part about this one. But I didn't teach it, but I've given you the assignment to do it. But most of you can do it. But you have learned some about in IGCSE.
Relative speed of approach and relative.
That is one concept about the relative speed. So first of all, we need to introduce one concept. It's called reference frame.
I learned all of this. I just watched like a bunch of videos on minute physics. Yeah. It's not a minute.
Reference frame, physically, okay, roughly speaking, is just the place where you take those measurements. The place where you take those measurements. So roughly, you can say this is a observer. Why there are different reference frame? Because just like when in the MTR platform, when you are standing on the platform, and the one sitting inside the MTR, you will measure different values of velocities when the train is moving. So there are at least quite many difference of reference frame. But mathematically speaking, reference frame is the coordinate system. Can you see? There are few reference frames that is very, very important. The most important reference frame we call inertial reference frame.惯性参考系 Who can read Chinese?
I can read 相对象征.
But not fluently. No.
Some easy stuff.
No.
Spanish.
¿Cómo está?
So you say it.
¿Cómo? 参考系惯性参考系 So this reference frame is a frame where my first law holds. Newton's first law. So that means Newton's first law does not hold in some of the reference frame. Yes, actually it does not. So the statement in your textbook is not rigorous enough. So you should say that for Newton's first law, it should be like in inertial reference frame. The object, if there's no net force acting on the object, then the object will move with constant velocity or at rest. So just give you a counter example. Just like inside a train, the train is accelerating.
So inertial reference frame is when like Newton is a reference frame in which Newton's first law doesn't hold.
Does hold.
Does hold.
Holds.
Oh, okay.
So if there is two men sitting in a car, which is accelerating to the right, at the same acceleration. So is there any net force acting on these two bodies? Yes, because they're accelerating. But when A look at B, A thinks that B is at rest, stationary. So it
That's not.
violates what the first law in your textbook. Because, but actually it doesn't, because it is not an inertial frame. Okay. Now first of all, then we should give some examples of inertial frame. Earth is actually approximate an inertial frame. Although you know that Earth is rotating around the Sun is rotating about some points in the galaxy, Milky Galaxy, and the Milky Galaxy is also rotating around some point. Yeah, so everything is moving with some acceleration. And then, but luckily, okay, the Earth is roughly a good inertial frame. The first law holds on Earth.
What will happen if it doesn't hold on Earth?
If it doesn't hold on Earth, then everything may be quite strange on Earth. That means Newton may not discover this law so early.
Hey, but how would it not hold? You mean like the Earth is accelerating in rotation?
If you learn later on, let's see if you have time, and learning about the general relativity, or we have some idea about that one.
Looks like we watched the physics course.
And also, just give you an idea about the inertial reference frame. There's a story that if you are inside a large ship, okay, in a prison, that means in a dark room, okay, you can't see outside. Even you have the most expensive apparatus in the room, you can't tell whether the ship is moving with constant velocity or at rest. Except you have the GPS, okay? Except you have the GPS, you can tell. But you can't tell without communicating with the outside.
It needs to have a reference point.
Yeah. So this is an idea about the inertial frame. So that means the inertial frames. There's some ideas. There is the frame which is moving at constant velocity relative to another inertial frame. It's also an inertial frame. So that means there's not only one inertial frame. Actually, there are infinitely many inertial frames. Infinitely many.
At any what?
At constant velocity relative to another inertial frame is also an inertial frame. That means like the Earth is roughly an inertial frame. If you're driving with a car at constant velocity, your car is also an inertial frame. Actually, that means there's no absolute space. You have learned something about special relativity, and then initially everything think that there's something called absolute space. Okay, let's go on. Some other frames that are quite important. One is LAB, the laboratory frame. Okay, that's the frame inside the lab. We have this name, so I introduce this name to you. Another one is COM frame. COM. Do you know what's the full name for COM? Center of mass. If you have learned about the concept about momentum, have you? No. No. Yes. Not yet. In a center of mass frame, the total momentum is 0.
And you're just right. I got the negative. Yeah, I got the negative. I forgot to add that in. Which just makes sense. I need to find a little code.
Yeah, even if it is negative, and if the question asks you for velocity, you just put 1 negative 1/4. But if it asks you for speed, you just plug in positive no matter what.
Wait, no matter what. So this should be positive.
No.
Oh, the end is.
And only the end.
What's the last?
The frame in the laboratory. The frame in the laboratory. Left frame.
Wait, where is this con frame?
We will learn it later on after we have learned about center mass. So let's go on. Okay, then let's talk about Galileo transformation.
Reference frame. Relative motion.
Too bad, right?
I think it's Galilean transformation, whatever, okay? Something like that. That means the transformation made introduced by Galileo.
What about
Galileo transformation. Now just say here is 2 men. This one is stationary. The left hand side one is stationary. The B is moving with constant velocity. Let's say U, okay? Then there is another object. Another flying object. Just say there's some object, okay? Moving. With constant So the distance between A and B is U times T. Speed times time.
Equals distance.
And the object is moving with constant velocity v. That means here is v times t.
So we see, right? Because inertia will be c, right?
Oh, that's the change.
Isn't that,
X is the
sir,
change.
isn't that just
VT is the
isn't
distance.
that just t v minus u times t x?
Use is the use from rest to right to
Yeah,
the
x
Mm.
equals v minus u times
Mm.
V
Or
minus
draw it more in general in terms of the coordinate system.
oh graphically.
Oh. Oh, sorry, I should add a pine here. Even you don't get this idea, I think the later concept, you can get it easier. Very easy.
Lorentz transformation.
No. About how the velocity transform. Of course, you can read from the, what does it mean by x pi? X pi is measured from the blue coordinate system. So it's a x pi.
Coordinate system.
Blue coordinate system.
Oh.
So the length from here to here is x pi. The length from here to here is x. Okay? And then x pi x, and the length here is u times t. So you get a very simple formula. X equal to x pi plus ut. And roughly speaking, if we divide this formula by t,
Yes, you.
okay, x over t is actually the, if a is moving, okay, x over t is actually the speed of a.
Yeah. Distance over time.
Mm. It's actually how the formula proof, but you don't need to remember the proof. And then it's not or more not obvious or not illustrative to understand this like this one. So I give you one example. Just like there's a two banks, a bank along the river. The bank. The bank along the river.
Oh, river bank.
If, let's say there's the water flow. Water flows at speed u. And ship.
Without acceleration.
No. Constant speed. And ship moves at speed v in still water. I tell you clearly, it's in where. That means if the reference frame is still water, the ship moves with constant speed v. And then find if the ship moves inside this river, what is the speed?
Against your weight.
If it is along the direction, then it will be v plus u. Okay, is it obvious?
I thought it was going to go like horizontally. Yes.
That means it is 顺风. How can it? What is it in Chinese?
Yeah,
Sudu.
Singaporean can Chinese.
Singaporean.
Sudu. Speed.
Is that?
What?
This along. That means it's travel along the direction of the media. That's the water. That have the speed v plus u. Okay. Obvious.
Yeah, I thought.
Obvious. Okay. I'll give you an example. Just say there's 2 points, A and B. An airplane traveling from A to B. Okay. traveling to A to B, and then from B back to A. And then the wind speed is from A to B at constant speed, u. And the aeroplane have the speed v in still air.
Is that the aeroplane
Hmm?
wing?
The direction of the airplane.
Wait, what's that line at the bottom?
Oh, that means the direction of travel of the aeroplane.
Oh, okay.
It's travel from A to B and then B
Do
to
you
A.
need to involve any displacement?
Or just let it to be L.
So it's just 2
Do you think it will travel? You need to go a round trip from A to B and back to A. Do you think it will travel? It take longer time if there is a wind, or a shorter time if there is a wind?
If the wind in one direction.
From A to B.
No,
No.
it's same time.
If just from A to B, it will use less time if there's some wind.
Yeah.
But it will take longer time from back B to A.
So really equal.
Lah.
No, from A to B and then B to A. Average speed.
And then if just A to B and B to A, and then you say one is long, one is shorter, so you cannot compare the total. You don't know whether the sum is longer or shorter. So let's do some calculation using mathematics. Now, if there's no wind, the total time should be 2L over V. This is very simple. The distance. With wind, you need to carry time into divide in two parts. One is V minus U, and then one speed is V plus U. Okay, and then you need to compare these two time. What can you do next? Is simplify. Okay, simplify the formula.
What is L?
The distance between A and B. Distance between A and B. I hope you can do the right hand side by heart. Mentally, okay? Don't need to write down.
Yeah.
Makes sense.
Oh, which one is larger?
Wait, we need to compare.
Oh, okay. So what I will do next is divide the right hand side, the denominator and numerator by V.
So,
It's V minus U squared for V. So which one is larger? Left hand side or right hand side?
Right, left.
left, left, left.
Right. It's right.
Left hand side, not right.
Right.
Wait,
The right hand side is
Because it's
long
larger
time.
at the bottom, so it's small.
So you look at the denominator. This one is smaller. It minus a value. The denominator is smaller. That means
maybe.
the total value, the fraction is larger. So this one is greater than this one. Okay. Now this is just a straight line relative motion. Let's go to two-dimensional. Okay.
Two-dimensional motion.
So this one is greater than 2L of V. Okay. Now you need to do it. You need to know how to do it by yourself to compare these two values. You need to improve your math skill. I feel if most of my students think that their math skill have improved after paying this commission.
I don't mind.
This commission.
Math skills.
Okay.
Math is too easy.
Really?
It's actually so easy.
Let me show you what mathematics I taught the students before.
Do we need to? I want to see. I think do we need to bother trigonometry?
Yeah, you need to learn it. Learn those trigonometry. Oh, not this one, not this one. Of course, not this one. Those are the math I taught those secondary students.
Yeah. I know this symbol.
Oh, limit.
So,
Logarithm.
is it communicated right now? Here.
Yeah, that's
I think you don't even know the symbols here.
standard deviation.
Wait, no, standard deviation is the other way.
Yeah, this is a partial derivative, partial differentiation. It's more easier than what differentiation you have learned. This is triangle.
Upside down, down.
Discriminate.
That hopefully, okay, you can learn it next year.
Wait,
I'm learning
what
it-
is the
I'm learning
difference
it this
between
year.
decision math and pure math?
Decision math is one branch of the mathematics.
What do you do in decision math? Make decision.
Decision math, we learn some about logic and some about the algorithm.
So basic for software programming.
So for all students, if you study computer science or you take this mathematics. So let's go on. No, let's go on to two-dimensional relative motion. One dimension is too easy. No need to learn it. For two-dimensional relative motion, now there's some very common example. Here's a bank of the river. The water flow with velocity u, okay, vector u, on the right hand side, u, vector u. So, if the ship is along one side of the river, if we want to move vertically, that means it's perpendicular to the river, in this direction, okay? So how should it move? A little bit on the left corner, left hand corner, okay? So that means it should a little bit towards this direction. Is it? But what is the angle in this direction? You need to find the exact angle. So what we do is
Why is it in that direction?
That's agree too. Nothing.
now the red arrow is the water speed, okay? Water velocity. And then the actual velocity, the velocity of the ship relative to the ground is the green one. So I write down the formula here. So the formula we learn is if the velocity of A relative to B equal to velocity of A relative to C plus velocity of C relative to B. So I state clearly here. Let me wait for me. Wait for me.
Wait, what's the green one?
Let me write it here. Wait for me. So the SG is the ship relative to the ground. Ship relative to the ground equal to the velocity of ship relative to water plus the velocity of water relative to ground. So you look at the color, okay? Understand by yourself. Look at the color of the arrows. Understand?
Oh, yeah.
Total kinetic energy
Jesus.
is some other form of energy, right?
Now, in this case, it will take the least distance traveled along the river because it's a straight line. But river is the shortest distance. I don't need to explain now this one. So what will be the time taken? What is the time needed? Given that the width of the river is d, what will be the time taken? Is d over the velocity, the green arrow, okay, the green arrow. How to find the green arrow? By using Pythagoras theorem.
Oh, yeah, that's what I said.
That is v squared minus u squared.
Wait, how is it green arrow?
Sorry.
Square root v squared minus u squared. Understand? Now, this one take the least distance travel. How should the ship move such that it will take the least time
In that direction.
to go to the? Now, actually, if you think carefully, this one is the vertical velocity. Even the ship is moving, let's say, even the ship is moving in this direction, okay, the v is the final velocity. That means the relative to the ground. The time taken will only be d over v cosine theta. That's the distance d over the vertical components of the velocities. Okay?
Yeah. So you should move straight down.
So how can it move such that it will take the least time? It should move down. That means the
Incline is to the right.
the velocity relative to the river should be downwards. And then the velocity of the water to the left. And then the resultant velocity is along this direction. It will take the least time. The time taken will be only d over v. Okay? d over v. The vertical component only. So it will travel along this direction until it reaches the river. So we know that the vertical distance here is d. How about the horizontal component? What will be the value here?
Which one?
Here, this one. This distance is given d. What will be the distance here? Like you have already find the time t already. The time is d over v. How about the distance here? You have learned about projectile motion, Oh no, the form 5. Huh?
Not yet.
Not yet. How about the distance here?
I can only use math. This.
Mathematics are only.
So hard.
But there
D is
here.
v times t. How about this? The distance along this side is u times t.
I said
Yeah. So it's u times t. That means du over v. Okay. Not hard. Oh, I should give one condition. Now, this one is valid only when v is greater than u. If v is less than u, then this is not the case.
oh that's imaginary number.
They will be given an imaginary number. In a square root inside will be negative.
Yeah, and
Then
then
that
no
means
solution.
not possible. It's not possible. But let's talk about that case. So, this one, listen carefully. This one is very, very difficult. Now, given that the water speed is greater than the ship speed, u is greater than v. Find the least horizontal displacement. Okay, you know what does mean by horizontal distance?
Yes.
That's the distance along the river travel. Okay, when you go to the so it will probably will go to in this direction. This one is very, very difficult.
Can you try?
Hmm?
Can you try?
This one is really, really difficult. Now this one actually there's some kind of question. That means you need to learn the solution first, okay? Otherwise you can't do it. In many of those Olympic questions, yes, you need to first read the solution. If you try and you can find the solution, that's very, very good, okay? But I can never see that students. Even I'm not those students that can create a solution by themselves, all the solutions by themselves. So the proper way to do it is either by calculus, differentiation, to find the least value, or drawing the graph. How to draw the graph? First of all, we know that the resultant vector is a vector sum of the velocity u and v. It's velocity u and v, the vector sum of u and v. So that means the vector sum of u and v should be closer, okay, to the dotted line here. That means the vertical direction should be closer to the vertical direction. Tired. Me too. You just need to listen. I need to talk. So, what does mean by u plus v should be closer to vertical direction? Let's have a drawing. U have a definite direction to the right, but you don't know the direction of v yet. And therefore, we can draw a semicircle here. It can point to any direction here. It can form a semicircle. So in which vector u plus v will have the most closer to the vertical direction? Now draw some. Now if you choose this one, then it will point here. Okay. If you choose here, it's point here. So you should choose the one.
Straight down.
Yeah. You can't no straight down. No, it's not close enough. The closer to it is the tangent.
Is it 45 degrees?
No, tangent to the circle.
Or tangent?
Oh, tangent too. Yeah, got it.
This line is the most closer to the vertical. Because if you look at the other line, it's more horizontal. Okay? So the vector you should choose, the velocity you should choose is the direction along the vertical here. Very, very tricky. That means the final speed is square root u squared minus v squared. And also you can find the angle here already. Huh? Hardly understand.
Yeah, I understand.
Some of the tricks in the commission is quite interesting, just like this one.
Using the right angle.
So just like these skills, I think very interesting, because it's so elegant. You don't need to use a lot of mathematics.
Sitting over here, I'm having difficulty just
Okay.
thinking on that.
So then this is the angle theta, okay? That means the velocity is a angle theta with a bank. The distance here is d. Then the vertical distance will be d sine theta. Oh, sorry, it's d over tangent theta. And the angle d, how can you represent angle d? And so in the commission, you can't write the answer in terms of theta. So how can you do it, huh? Considering the right angle triangle here is u and v and then square root u squared minus v squared. That means the tangent theta is v over square root this thing. Okay. I can send you some question later on today, and to check your understanding about this topic. Ha ha ha. Okay, this one is already one of the most difficult questions. We're talking about two-dimensional relative motion. We will teach one more lesson about relative motion, and then we can finish this topic. Okay.